In this video, I will explain you the working principle of a voltaic cell. In the last video, I have explained you the principle of voltaic cell. What is that? A molecule having certain amount of chemical energy now will become a new molecule comparatively having lesser chemical energy. Now the difference has been given to the system, right? So that is in the form of electrical energy. So here in this case, we have H2SO4 as a solution. So let me explain the structure. It's H2SO4 in a beaker. We are connecting two electrodes. Electrons are nothing but metallic rods. One is made up of zinc and other one is copper. Now the moment you are inserting a zinc rod, there is a potential of 0.76 made, that is negative 0.76 made, and here it is plus 0.34. The reason why this become negative potential and why this become positive potential you will learn in chemistry. So anyway, it's a negative potential here, a positive potential here. So in the last video I have explained you when H2SO4 becomes zinc sulfate ZnSO4 by reacting with zinc, certain amount of energy is released and this energy is given to charges. So charge carrying energy is nothing but electrical energy, right? Now how this process will occur? So H2SO4 has an affinity towards zinc. How? H2SO4 has two H plus, one H plus and one more H plus, and these hydrogen molecules with the charges are now bonded with SO4 2 minus. So it's a electrostatic bonding. Okay, now to accept zinc and keep it here, we need Zn2 plus. Then only there will be an electrostatic force of attraction. See, it's the charges do attract in between. So, correct? Zn2 plus and SO4 2 minus. If it is only Zn, then we can't make a bonding in between Zn and SO4 2 minus. So we can remove 2H plus here and we can insert Zn2 plus instead of that, keeping, so it's the same charge here, only different sized atoms. That's not a problem. So here in this case, Zn initially have to become Zn2 plus and 2 electron minus. Then this Zn can now combine with SO4 2 minus and become ZnSO4. Now these two electrons, it's a negative potential here, right? Let's say we have a battery, a positive and negative. When we are keeping an electron with the negative potential, this electron will go all the way till the positive terminal when we are closing the circuit. If we are not closing the circuit, this movement will not happen. So when these electrons are getting accumulated, the necessary condition to go to the other side or to create a current is nothing but closing the circuit. So when we close the circuit, the electron will go all the way from here to copper and the electron will accumulate here. Now the circuit is not closed. We can say a circuit is closed when a charge from one point goes all the way through the path and reaches the other side or reaches the same point. Now charges flow in this direction. Then only a current is made. If a charge goes from here till here, that is not current. Okay, it's a temporary current. We can't get a sustainable current from here. This will happen during charging of a capacitor. So when we are connecting a capacitor, charges will go and that will be charged at one plate of the capacitor. So we can measure a small amount of current for a very less amount of time. After that we can't measure it. Anyway, this is not a current. Okay, the point is there won't be any current. Charges will get accumulated here. Now, so anyway, charges have reached here, right? We have closed it. So charges have reached here. But if these electrons are given into solution, then I can say that, okay, from solution, the electrons have came, from this rod, electron have came, that has gone all the way through this one and then it has came and it has given to solution. Then there is a closed path here or there is a loop here or there is current going through the system. Clear? So these two electrons, what will happen to these two electrons? See, before in this example, it was 2 hydrogen and SO2 minus making the bond. Okay, now these hydrogens have got replaced. So H2H plus are there in the solution now. 2H plus are there in the solution now. Why? Because zinc from this rod has become Zn 2 plus and 2 electron minus. Now this zinc has came to the position of hydrogen. Now what has happened to hydrogen? 2H plus are there in the solution. Now these 2H plus, H plus and H plus will come here and will take the electron. So what will happen? 2H plus will go here and take 2 electron and that will become hydrogen atom. And this hydrogen gas will go up. So the whole process will be repeated. Zinc will release 2 electron and Zn plus will make a bond with SO4 2 minus. Okay, now these 2 electron will move here. Now when Zn 2 plus bonded with SO4 2 minus, there are 2 H plus in the solution. That H plus ion will now go to this copper rod and will take the electrons and releasing hydrogen atom. Whole process is going on. Till when? Is it till infinity? No. Till all H2SO4 has now been converted into zinc sulfate. Till then the process will happen. So that is the maximum chemical energy stored in a cell. So that is the maximum electrical energy deliverable from the cell. After that the cell dies. We cannot take current from the cell after the all H2SO4 has been completely converted to zinc sulfate. Okay, thank you.